This is the second in a series of video testing a DC to DC buck converter. In this video, I'll be testing a module that is capable of delivering 5 volts at up to 5 amps. The setup is pretty similar to the previous video, other than I've just added a multimeter to compare the load values. I'm starting with a load of 1 amp. I'm going to gradually increase it and see how the voltage drops as I add more. So at 2.4 amps, you can see the voltage drops below 4.7, which is my initial threshold. So I'm going to adjust the threshold to be at 4.4 volts, which was the threshold that I had set for the previous module. Okay, at 4.4 amps, again the voltage is dropped below the 4.4 volts threshold. Yeah, going back to 4.3 amps seems to fix that. So I think I'm going to need to adjust the voltage threshold again to a lower value to see whether I can actually go at higher amperages, at least above 4 volts. Okay, so at 5 amp we seem to have reached the advertised maximum amperage of this module, but we've dropped down to 4.28 volts, which is not ideal, it's less than ideal, but nevertheless it's still at 5 amps. So the other thing I want to test is, right now the input voltage is 12 volts. I want to see whether it would still provide me with 4.28 volts at 5 amps if I lower the voltage to 9 volts. Of course, the amperage that I'm going to pull from the source is going to be higher. Okay, so it seems to do that pretty well. It's steady on its voltage, and I'm still getting 5 amps from the module. So next, let's try and go at higher voltages from 12 volts, since the advertised voltage range is anywhere between 9 and 35. So I've increased it to 20 volts, and the regulated output still seems to be pretty good, which is 4.27 volts at 5 amps. So let's increase it further. Let's go to 25. Let's go to 30. Let's see how it copes at 30 volts. So 30 volts, I'm still getting 4.26, 4.27 volts out at 5 amps. And the circuit seems to be pretty stable. I actually tested for the heat that the module is emitting, and it was pretty reasonable. It wasn't too hot, it was kind of warm to the touch. Okay, so let's take it to its maximum input voltage of 35 volts and see how it works, how steady it is. So 33, 34, 35, let's get to 35. There we go, 35 volts input. And the output seems pretty well regulated. It's still putting out 4.25 volts at 5 amp, and it's pretty stable. And again, it's actually not warming up. So let's push this module a bit from a load perspective. I'm going to try and see how far I can stretch it from a load perspective before the voltage drops below 4 volts. The other thing to note is that the reading on my amp meter, my multimeter, and the actual reading on the constant current tester are pretty close together, so I'm very happy about the constant load current generator. It's pretty stable, pretty reasonable. The reading out is pretty accurate. This gives me some confidence for further testing as I do test more DC to DC modules. So we are at 6 amp. We are at 6 amp right now, which is almost 20% more than the advertised capacity. I would definitely not run that for a long periods, but it seems to hold itself at 6.2 amps, 6.3 amps is still above 4 volts. So I'm guessing at 6.4, 6.5 is probably going to drop down. 6.6, okay, 6.6, and we've dropped down to about 3.99, 3.98. And I'm checking the temperature with my temperature probe, and it is still below 120 degree Fahrenheit temperature. So the nice thing about this module is that unlike the previous module, I could not get it to overheat, and the voltage drop seems to be pretty linear. And as you can see, as the load has dropped to 3 amps, the voltage has gone back to a stable 4.41, 4.5 volts. So I'm pretty happy with this module. It's pretty stable. It does not heat up that much, and I think for the price it's a pretty decent bargain. Thank you for watching this video. I hope you come back. I intend to make more videos for DC to DC modules. I have quite a few modules. If you have any particular one you want me to test, please let me know in the comments.